Now friends, welcome to today's class. Today I have a very essential topic under chemistry. Now the unit we normally call thermodynamics, but the subtopic is electrochemistry. Yes, so I want us to cover that is thermodynamic as a unit, but to specialize on electrochemistry as a subtopic. Now here I have a very good example here that will enable us to get to know how calculations are being done there. Now the question here is, how long will it take to deposit 0.0235 moles of metallic gold by electrolysis over the compound of gold using a current of 0.214 amperes? The bracket is Faraday is equals to 96,500 coulombs. So this one is just mean 1 Faraday is equals to 96,500 coulomb. Now how can I perform this? So I'll now come here and write just the solution, and so as to see how we can solve that. Now to solve such like a question, there are several steps you must adhere and put in place. Step number 1, we've been told that here that to find the time, and therefore you need to be knowing the formula that will enable you to solve time, having been given that is moles as well as the amperes here. Now what is the formula you are supposed to use? The best formula I want to give you today is that because we've been given moles, the formula states that to get number of moles, we just write NO. This one mean number, so don't confuse it. So number of moles, the formula is to get IT. Remember, it is just the amperes times time over NF. So NF, remember F we've been given here. N is just the charge. Remember, the charge we shall be concentrating on is under gold, because that's what we want. Now, after writing the formula, what we should be doing is to see how we can get, for instance, number 1 moles, and already it is there, so there is no need of finding it. Then I have, that is I, it is here, that is ampere, it is 0.214 ampere, therefore it is there. Then time, remember, that's what we want to get here, because how long, that is just time. Now here, down here we have N, and I've told you that N is just the charge of gold. We shall see it because it is not here, and therefore the very first thing we need to be finding is to get the value of N. Now Faraday constant, we've been told that 1 Faraday is equal to 96,500 coulomb, so therefore it is there, and therefore our first step is to get N. Now friends, so as to get N, you need to be getting the equation of remember, this one is metallic gold. Gold always is a positively charged, and therefore it must be deposited at the negative terminal of the battery, and that is at the cathode. So step number 1, you shall come here and say that equation at the cathode. That is the first thing you need to be getting. Now, for you to write the equation at the cathode, you must know that at the cathode always electrons are gained. Yes, because at the anode you know that electrons are always lost. So electrons lost at the anode are being gained at the cathode. So that is it. And therefore we shall write the equation at the cathode showing that indeed electrons had been gained. And therefore, to show electrons gained, they are normally shown at the reactant side. So we shall show the electrons at the reactant side. That one we shall prove that indeed electrons had been gained. So I'll come here and say now, because that is gold, to write the equation on the cathode now, it will be, that is the symbol of gold is that way. Now gold a charge of 3 plus there, and it is aqueous because it is an ion, plus electrons are negatively charged. The product here, we need to be getting gold, which is a solid, because electrons have been gained now. Now you need not to leave this equation this way. You are required to balance the charges. Remember, when you come to the product here, the charge here is 0, and therefore I expect to get 0 at the reactant side. Now here I have gold, it's already positive 3, and electrons is negative 1. Therefore when I leave it this way, that one will mean that it will be 3 minus 1, which is 2. But here I have 0, and therefore I must see the value that when I put under electrons here, I'll be getting 0. And therefore since here is the 3, that one will mean when I put here 3, that one summarizes that electrons shall be 3, so I'll be having negative 3, so that when I take 3 positive 3 minus 3, I'll be getting 0. So here I shall be remaining with 0, as well as here is 0, and therefore you balance the charges. Actually, that's how we can balance the charges of a chemical equation. Now after writing this equation, remember our main concern was to get the value of n, because we shall be using it here. That's why we come up with this equation here. Now from the above equation here, we realize that the charge is now 3 under n. So you will come here and say n now is equals to 3, and therefore since both number of moles, that is amperes, Faraday constant, you are given, and right now you have n. Your work is just to substitute, because you now have everything there, and therefore you just substitute. Remember, we were told that the number of moles is 0.00235, so that's what we write here. So I'll come here and say, therefore 0.00235 moles now is equals to I, that is ampere here, and it is 0.214 times time. So I can just come and say that is time there. Then it is over n, and what is our n here? N is 3. So you shall just come here and say that is 3 times the Faraday constant, remember, and the Faraday constant here is 96,500 coulomb. Friends, while working out this, remember I can come here and cross multiply, whereby I'll now come here and say it is now that is 0.00235 times there is that is the denominator here, so times 3, this one times 96,500, this one here is equals to the numerator there, that is 0.214 t. Friends, to remain with the t here, because that's my main concern, I'll divide by 0.214. I divide by 0.214. When you do such, this one goes, and you shall derive your t as we want to see here. Now when you display everything in the screen, so let's see, that is 0.00235 times 3 times, that is 96,500, obviously that is 680.325. when I divide by, that is divided by 0.214, I'll be having 3179.09. when I round off, you can as well round off the way I've done. Now this one is seconds. Now this value here, I can as well convert it to minutes. Yes, because I know that 1 minute is equals to 60 seconds. Therefore when I come here and divide this by 60, I'll now get my time in minutes. So when you come here and divide it by 60 there, you shall come up with 52.98 minutes, whereby when you round off, because this is 9, when you round off here, it will be now, that is 53 minutes. Now after getting that is 53 minutes, you will have solved the time, because they wanted time, and you shall have gotten the answer. Otherwise, note the key areas I was putting in place so that you get to know how we can solve such like a question. Otherwise, let's meet in the next class. Bye.